What a great honor to be here with you. My name is Denis, and in my role of worldwide tech leader for AI/ML, I own the machine learning specialist solution architect function. These are all the technical experts that day in and day out come and help customers adopt AI and ML technology. LinkedIn is often an option if you want to follow me, but there's also a Twitter handle on screen. Today, I want to talk to you about the machine learning journey and how you, as leaders in your own organizations, can help accelerate it. But first, there's quite a bit of confusion out there. We talk about AI, ML, deep learning. What is the relationship between these three? If you look at publications and various posts out there, it's very difficult to make sense of what's going on. And so I thought I'd just bring you some examples of that. Here's somebody's attempt at kind of linking the three. Very thin sliver of intersection between AI and ML. Venn diagrams, of course, are very popular. Here, somebody figured that deep learning is really part of machine learning, but AI is still sort of on the side, so not quite clear. What about NLP? Well, it's probably actually sort of accurate, right? Natural language processing, understanding is connected, but maybe not all about AI. If you don't like circles, right, we can go to boxes. And it's amazing in how such a simple diagram here, it's easy to make some confusion, right? What do these lines even mean? If you think it's easy to confuse people with just a few boxes, how about this one? I'm not sure. Mathematics seems to be not related to machine learning in this case. I won't go too far into this. And of course, deep, right? The deep analogy, the deeper you go, the heavier gear you don as a diver. Somebody heard that deep learning is sort of related to neural networks. But is deep learning inside the neural networks, or is neural networks inside deep learning? Not quite clear. What about expert systems? Remember those? Again, is that part of artificial intelligence? Not according to this diagram. And finally, we're getting to something more reasonable. And you see that deep learning is really a special kind of machine learning. And all of this is trying to solve a big problem of AI or building artificial intelligence systems. And what I like about these diagrams is we also see a timeline shown. Early on, we've started with systems where people try to cram knowledge and facts into the system manually by hand and then hope to derive some useful information from this. And at some point, the realization came that it's not possible to do it manually, right? You need to have machines doing it on their own, and hence we come to the age of machine learning. And today, both AI and ML, we often see it together, right? It's virtually the same thing because you cannot do modern AI without ML, right? That's the big thing. And of course, deep learning with the advancements in compute, specialized compute, and neural network algorithms, and general kind of function modeling, we come to these better techniques. A big question often is, well, OK, I sort of understand what is machine learning that's not deep learning, you know, maybe decision trees, maybe your regression. But what is AI without machine learning? It's kind of hard to go back. And in some ways, we forget that we carry this AI in our pockets. Because when you try to navigate from point A to point B, you know, you really don't need machine learning, right? All the information is already there in the form of a map, and we're just trying to find the shortest route from A to B. So navigation would be an example. And of course, there are many diagrams of this kind, quite a few variations. Again, if you don't like boxes, you can go back to circles, and so on and so forth. So with so much confusion in kind of general public space, it's not surprising that we come across machine learning practitioners of all forms out there. And that is why our approach is layered. We're trying to cater to machine learning practitioners of different level of skill and experience. So kind of Puneet, I think, alluded to this machine learning stack. But if you look at this diagram, at the very bottom layer, right, we have the so-called frameworks and infrastructure. If you are an experienced deep learning scientist, you can just grab a powerful GPU, right, with Amazon Machine Image that has already all the drivers that are necessary for you to do the job, and off you go. You're happy to do everything on your own. But if you're an experienced developer and you want to integrate your AI technologies into your application, we have, on the other end of the spectrum, right, the AI services layer. For the most part, this is where the models have already been built for you. You don't need to collect a lot of data, right? You could just call API and integrate intelligence into your application. So, for example, Amazon Poly, right? If you want to take Hindi, right, and generate spoken kind of Hindi, that service is there for you. But this distinction of no models needed to be built has started to kind of blend a little bit in that there are new services such as Forecast and Personalize, where we're helping you with these managed services to build a model that's custom to your data and custom to your application. And so most recently at reInvent, we've launched some new services into this layer. So if we talk about smart enterprise search, that's Amazon Kendra. Fraud detection, so there's a fraud detector service that's custom built for this. You have Code Guru, which is a machine learning powered service that improves software development process with smart code reviews and profiling built into it. Then, of course, there is the contact lens for Amazon Connect, which enables you to extract insights from customer kind of interactions with contact centers. And then there were some additions to existing services like Amazon Transcribe Medical, right, focusing on the medical vocabulary, and that's quite important. And even before reInvent, we've launched so-called custom labels for Amazon Recognition, where you can now analyze objects in your photos and detect custom objects in there. And of course, the middle layer in this three-layer stack is our platform layer, which is really Amazon SageMaker. That has so many features that I could probably spend a whole day talking about different features in detail, right, and different functionality, starting from labeling in the form of ground truth and so on and so forth. And most recently, we've announced SageMaker Studio, which is a specialized integrated development environment, if you wish, for data scientists. So you don't need to work with AWS Console anymore. You can launch serverless notebooks. You can look at various experiments and trials that you can launch. You can debug your machine learning models, and even build models automatically using SageMaker Autopilot, which is also quite exciting. So, machine learning is really not just an aspirational technology anymore, right? It's pervasive to many, many different industries. Take, for example, John Hancock, which is a life insurer in US. And they're actually using contact lens for Amazon Connect to gain insights into these customer conversations, understand what is working and what is not working with their customers, quickly iterate, and improve the situation. Cerner is using Amazon Transcribe Medical to process the recordings and to extract useful medical information from those recordings. Additionally, they've used Amazon SageMaker to build models on congestive heart failure that is predicting 15 months in advance, right, that something might happen. How exciting is this? Like, this is really changing people's lives. And, you know, agriculture and farming. Tina is a dairy cooperative in Norway, and they've actually collected and keep collecting millions of records about cows that are in those dairy farms. In fact, they probably collect and have more information about cows than a lot of humans have about themselves. And all of this with the goal of building models that predict health, predict milk production, and obviously this is important for the dairy industry. In fact, you know, across various industries, IDC predicted that by 2021, the spend on AI and cognitive technologies is going to be, you know, over $50 billion. So how can companies incorporate and take advantage of this technology? Right? We're seeing, you know, low-hanging fruit such as automation. So for example, NASCAR is using a variety of services such as recognition and transcribe to, you know, extract useful metadata in their many, many videos, right, that they have to enable faster discovery and better search. So these are low-hanging fruit, but they're still very important. The other benefit is augmentation of data. So helping humans make better decisions. And a company like FINRA is using Comprehend to go through many records and discover actionable records, something that, you know, records of interest in that industry, to be able to help focus a human reviewer on those faster. A third benefit is enrichment. So adding machine learning and adding new functionality to an existing product. So Intuit has built an expense finder tool, and is using SageMaker to go through a year's worth of banking transactions to automatically find good options for, you know, tax savings. And on average, using this technology, they've been able to find over $4,000 worth of savings per average customer. So very important, very tangible, of course, especially to those customers. And invention, of course, is the fourth benefit, which is quite important. There are some companies out there that are built on machine learning applications from ground up. And Convoy is one such company. It's Seattle-based, and it's disrupting the kind of logistics industry by improving the matching between the truckers and the shippers, So this is highly important, and there are many, many examples like that. And of course, this is the ultimate differentiator, right, for a business, to be able to innovate ahead of others, ahead of competitors. So adopting machine learning technology is not easy. There are cultural changes that are often required, and it's not, many customers are telling us that it is not easy to get there. Oftentimes from, an idea of what we can do, we get a lot of excitement, but then companies realize we need to hire people, we need to do a lot of training, we need to have the right tools, and as a result, it takes a long time to get to a proof of concept, and even after that, right, we need to productionize the technology, make it scalable, and with machine learning, 90% of cost is in inference cost, right, once you're running the machine learning model. So you need to make sure that your machine learning deployments are cost effective. So in our approach, we're trying to make it easy for customers of all levels of experience to adopt the technology. It's not always smooth sailing, of course, but we're there to help. And that journey requires key kind of steps. And this is what I'm trying to show you here. First and most important is a cultural change, right? Because machine learning is not just a one-off single project. You need to invest into the future, or for the future. So you need to have a corresponding change in culture. So championing machine learning culture is key. 10 years ago, Amazon leadership asked every single business, not just machine learning focused areas or data intensive areas, but every single business from HR to fulfillment centers, and to how they can incorporate machine learning technology into their business. Have a plan, right? And we don't plan to use ML was not an answer, right? But this also required kind of transformative change. What about the resources? Who are going to be helping these machine learning projects? And historically, Amazon, when I joined the company almost 15 years ago, right, we didn't have scientists, so that many scientists entitled. We hired people who could build. So those were people with scientist background, but who also have an engineering and builder mindset, and this is important. And then, of course, you need to know where and how the data is going to be obtained, stored, and accessed. So you have to focus on the data strategy. That's really key to enabling your machine learning practitioners in quickly iterating, because you don't want to hire these bright people to only spend 90% of the time wrangling data. And of course, the pool of talent is still limited out there. We're seeing tremendous growth and interest, and you're all here tonight. Probably, if you ask yourselves, would you be here if machine learning was not such an important and such a publicized and technology that we've heard about? There's been quite a few people who've joined the machine learning and AI camp, so to speak, and we're extremely excited in seeing more and more folks continue to exercise, practice their trade, but help is on the way, right? Because we also offer training and certification, and now partners do as well. So That pool is increasing, and this is exciting for me. I've been last week at NeurIPS, which is one of the premier machine learning conferences, with 12,000 people in attending, probably more. It's incredible. And of course, once you have all these pieces in place, right, you have your data strategy, you have folks hired, you need to focus on the right business problem. Amazon itself started with, recommendations and supply chain problems. You could say we wrote the book on recommendations 20 years ago, more now. And over time, a lot of these innovations led to other things, such as Alexa and Prime Air and so on and so forth. But it's not just Amazon who could do this, right? Here's a company that probably is not associated in your mind with machine learning and technology, and yet they've been able to incorporate AI/ML. What you're seeing on screens is the Formula One insights, where using SageMaker and all the sensors that are installed in cars, for every run, there's like 3 gigs of data collected. They've been able to do things like predicting the pit stop and when the tires need to be changed, and actually sharing those insights with customers, or with viewers. So here are some of the questions you need to ask yourselves when choosing a use case. Is it important enough to get attention and get adoption? I'm not going to go through all of them, but my favorite is, does it require machine learning? I've actually met a customer, and I walked through a use case with them. We talked through all kinds of options. They explained the problem to me, and I said, well, it seems like you could probably use statistical methods here. Why are you looking for ML? And they told me, well, we've already announced to our shareholders that we're going to have machine learning built into this product, and therefore we need to do it. So that example aside, there are actually many good problems where machine learning can help. And once you choose a use case, scaling it could be interesting problem. So we're offering customers SageMaker as an overall platform that enables you to go from labeling to training in the cloud to then deploying and building production endpoints that will do auto-scaling for you, not something that data scientists typically are comfortable doing. So there's lots of help for you there. And before I end, I wanted to show you an interesting example that I've been able to extract myself using SageMaker. So using a built-in algorithm called blazing text, I've been able to take the entire Wikipedia contents in Hindi, downloaded that in SageMaker, and then applied something called word2vec, which is part of the blazing text algorithm inside SageMaker. What this does is it turns every word in Hindi into a 100-dimensional space. So it's mapping words to a numerical vector space. And then once I do this transformation, this is called embedding, I can then plot all the words that appear, and automatically this system lets me discover relationships between words that I, not speaking Hindi, not knowing the language, can see and take advantage of. So here's an example of a TSNE plot, plotting the 100-dimensional space into just 2 dimensions. And because I don't read Hindi, I used Amazon Translate to translate those 400 most popular words in Wikipedia and plot those instead. Right? So here's an example of these dots representing each word. And you can see that some words are linked together, and the words that are close together in this plot probably mean something similar or related in the semantical space. So just to give you an example, here's a grouping that it found, which includes words like birth, death, father, family, home. It's recognizing the fact that these words are related together. They're about something. In that 100-dimensional space, they're appearing closer together. Here's another grouping that it found, right? Something about nations, British, Indian, American. In fact, one of the words here is called combined, but it's actually united, right, as in United States. That's why it's also overlapping US. And, of course, sports, cricket. You could see the concepts of sports, games, match, team is all linked together in that space. So if you want to learn more about the techniques used, there's a YouTube video that actually got released at reInvent. Just search for AIM 375, and you can get more details about this approach. So with that, I wanted to end. Thank you very much